part of lecture 10. We will be talking about repair of composite structures. Why do composite structures need to be repaired? Because they can get damaged, and because many of them are thermoset in nature, they have damage that is pretty substantial. I mean, there can be big block holes, and that dramatically reduces the mechanical integrity of the structure. But the good thing is that composite structures can be repaired in order to recover from that kind of a damage. So, what types of structures can be done? So, especially if there is a crack or corrosion damage, um, it can create catastrophic failure or costly repair in either a metallic or a composite component. So, in the standard composite structures are, um, we know that they are either mechanically fastened or adhesively bonded. And there are some advanced repair methods where they can be patched up, just like you do in the roads and things like that. So you would put some kind of a patch, and the way you put the patch, you want to make sure that you recover most of the strength of the properties. Yeah. So we did talk about a little bit about fatigue properties in metals and composites. So um, in aircraft structures, if it is a metal, they are tension dominated properties, and if it is a composite, then it is a compression dominated property, especially if it is an upper wing skin type of a material. And you can see that the graphite epoxy type of materials, they have a much higher fatigue property compared to aluminum type of structures. And typically these are the design strains required, or the design stresses that are required for this is with strain. I mean, you are plotting peak strain versus number of um, cycles here, and you can see that they undergo tremendous amount of strain. And in the case of graphite epoxies, the type of strains that they undergo are much lower than that of aluminum type of structures. And the more number of cycles, the higher the strain that they can undergo. So when is repair required? So when you do quality assurance, quality control, or quality checking, you may want to see that you may want to ensure that you can repair the defect, or if during service, if there is a damage, then whether or not um, that damage can be repaired from. So in this case, you would uh, write what is called a discrepancy report from what is required to what you are observing. So in service impact, most of the time, if there is, especially if there is a low velocity impact, there can be delaminations that are introduced into the structure, and these delaminations can grow as a result of number of cycles and can damage the entire structure. So depending upon whether the impact creates delaminations or not, and whether or not the component is under tension or compression, depending upon the impact energy, the properties can be lowered. So, for example, if the material is under tension, depending upon the energy, so low velocity impact, so even 3 joules impact, it could be just with a hammer. If you drop a hammer on a composite structure, it can create delaminations, and it drastically reduces the tensile properties. So from 750 to approximately 450. So that is what? Approximately 30 to 40% reduction in properties. And compressive properties also drastically reduce from approximately 600 to less than 300. So again, 50%. So it does not take a whole lot of impact energy to create that degradation in properties. So the quality assurance people have to classify the repair required. And unfortunately, the repair judgment is more of an art rather than a science. So you have to apply your judgment. And there could be some explicitly stated criteria, but still, um, it is not 100% absolute, if you know what I mean. So there are repair classifications, and so whether or not you need to rework the material or whether you can use standard repair, and if the damage is pretty um, um, severe, then the materials review board has to get together, where they have members from the quality assurance and engineering people also, and they have to make a determination whether or not this component can be continued to be used, or they need to be repaired, or whether it needs to be scrapped. So there are several examples. So the standard one is cosmetic damage. It's very negligible repair, and if it is non-structural, then you just need to bring it back to the required finish of the component. Class 3 is minor structural repair. So where you can have standard repair procedure. Class 2 is major structural repair, but again the MRB may not need to get in place with that. And the class 1 is the most severe kind. It is major structural repair, and after you repair, the MRB needs to get together and analyze and evaluate whether or not this component can be accepted or not, or the repair can be accepted or not. Okay, so what kinds of repairs are possible? So the first kind is bolt-on repair. The second kind is you can fill it with resin adhesive syntactic foam. So you mix all that together, and you just like you see on the roads, like the concrete, not concrete. What is that? The you just apply that, and it is patched. But unfortunately, as you can see, continued use of that component can kind of remove that material, and especially if there are cracks in there, there can be some ice and water and all that can enter in there, and that can expand and contract at different rates, and it can cause to cause continued damage. The third kind, which is the best type of repair, you remove part of it and you create some kind of a scarf area that is resembling a scarf, and you patch it with new material, new composite material, which would be pre-preg layers and things like that. And you need to, so for every inch in thickness that you need to remove a total area that is 50 times that. So if it is 1 inch, you need to remove an area that is 50 inch by 50 inch in order to repair that place. So what types of repair materials are available? Um, the most common kinds are you use some kind of a resin or adhesive that has a right viscosity, cure time, and temperature. So, because this whole component probably cannot be put back into an oven or an autoclave. So you may need to do the repair outside. So out of autoclave type of repair. The other kind, the most common kind, is you add the syntactic foam or foaming adhesives into the resins, and then you make it into some kind of a thick gooey stuff, and then you just patch it into the damaged area. Or you may take reinforcing fabric, a pre-preg fabric, or you take milled fibers and you add it to the resins, and then you can again patch it into the uh, damaged area. The other kind would be pre-impregnated fabric and tape. So what are the advantages of wet systems? Most of the time you can do curing of this area at room temperature, and you may need to use some kind of a rolling uh, equipment, and you can roll that and you can apply some amount of pressure and make sure that it is well um, inserted into the cracked area, and you just need to use minimal amount of pressure, materials, and equipment. If you use a pre-preg system with fabric or with milled fibers or chopped fibers, the advantage is that you can control the amount of resin that you are adding into the material, and it is a cleaner system to work with, and it may provide a better match with the existing material. So the standard one is the Vichitech composite repair systems. So you can go there and check there. I mean, they have multiple systems there, and you can see that um, it's a pretty standard process that they have, and uh, it's a it's a process that can be it's a this process has been in use for quite a long time. So you can get properties that are consistent. I mean, you may not, I mean, like, if you have a repair to be done, the component after repair may not have 100% of the properties that you started out with, but the amount of properties that you get is consistent, and you know how much you are getting back. So, what are the types of repair procedures that you use? Um, Essentially, it's a four-step process. So first and foremost, you have to prepare the surface. Why do you need the surface preparation? Because if there is dust and moisture and things like that, you need to make sure that it is completely clean. So when you apply the repair patch, it ensures that the material would bond well with the underlying substrate material. Then you apply the material, then you have to cure, where you can control the time, temperature, and pressure. And then after it is done, you take out all the extraneous parts, and then you have to finish it, make sure that it bonds well with the underlying substrate, and it also matches with the profile of the underlying substrate. Why? Because if it is a wing structure, for example, a wing structure or some kind of a structure like that has aerodynamic profiles. So if your repair or patch is kind of um, doesn't match with the profile, then you are going to mess up the aerodynamic profile of your component. So you have to make sure that everything is perfect. um, and it does not affect the service conditions of your component after repair. Okay, so what is the first step in repair? You have to determine the extent of damage. You have to know what is the structural material to be repaired, whether it is metal, composite, or a sandwich construction, and uh, what is the type of component to be repaired, whether it is a skin, spar, rib, wing structure, etc., and how much is the type and extent of the damage, whether it is a fatigue crack or a corrosion or impact damage, etc., and the after repair, what are the load levels and fatigue spectrum experienced by the structure, and how much is the material thickness to be repaired, and you also have to know what is the skill of the available labor. So you have to make sure that the person who is doing it is well trained in the repair structure. For example, um, if you talk to any composite uh, shop or uh, or where there is repair and refurbishing going on, they need people who are well versed in repairs, composite repairs. The last two are pretty standard. I mean, I think that is not that big a concern. You are going to have availability of repair materials, and you are going to have access to the repair facility. But the skill of the available labor is definitely very, very important. So this is a schematic of the structure, I mean schematic of the process for repair. So it's pretty straightforward. Um, so what is a bolted repair? A bolted repair is you take a patch or you take a plate and then you bolt it onto the underlying substrate. But if you are going to be bolting it on, you have to make sure that you're drilling a hole into the composite structure, and you have to make sure that the drilling process prevents the splintering on the exit side of the hole. And so when that is the case, you would put some kind of a back support so that the material doesn't spray out through the bottom and damage the material, damage the structure. And why? Because the matrix in the composite is brittle, because especially when it is not hot, or after it has been cured, it is going to be brittle compared to the metal. So uh, you try not to have some kind of a rivet, which is not a good thing for composites. And the other thing to note is that the way the fasteners will behave under some kind of a stress is going to be different from metals. So the load distribution is not going to be uniform between the composite structure and between the uh, bolt material. So you have to take all that into account. So this would be a standard thing, standard schematic of that process. So it's a pretty involved process. So you have to drill several holes, and those bolts have to be flush with the plate. I mean, so it can be a metal plate or it can even be a composite plate. So bolting is not the most ideal composite repair method. The most common and useful repair concept for a composite is bonding. So And why? Because it can restore greater strength to a damaged composite structure as compared to the bolting type of a repair. And there are repair patches that you can buy from companies like AirTech, and you can make sure that it is the same material as the underlying material, underlying substrate material, so that you get similar properties. I mean, it may not be 100% uh, back to what it was before the damage happened, but it'll be like 80-90% of the original structure, which would still be okay and acceptable for the structure. So the most common repair concept are what are called step lap or scarf repair. So step lap is you create some kind of a step in the bonded area. Suppose this is a damaged area. You remove material in a stepwise fashion, and then you put the patch in the area. Okay, and then you ensure that it is well bonded with the structure, and then you have a top layer, and then you have to make sure that it matches with the profile of the upper structure. The um, the advantage is that the structure is has pretty good strength, but the problem is that there is shear stress at these edges at the end of each step, and so there are some disadvantages for that, so you have to take all that into account. What is a scarf repair? Scarf repair would be, so you are adding external piles for strength, and this configuration can restore the, I mean, it is the best type of repair method, and it provides smooth load transfer through gradually sloping scarf joint. And if you have designed the scarf joint properly, then you can usually develop, it won't be 100%, but it will be like 90 to 95% of the undamaged panel. And the patch material is usually cured in place, and so therefore it must be supported during the cure. So it must be kept under pressure and things like that, so that it bonds well with the underlying substrate. So this would be the schematic for a scarf repair. So here the scarf area is straight, so that this material that you are adding in matches well, and the profile is well um, matching the original structure. You can do the same kind of a structure for a sandwich type of a construction. So if there is a damage here, you have to remove the whole thing, and then you have to, um, and then the top layer is kind of delaminated from the underlying honeycomb core, and then you have to make sure that it is flat and things like that. So how do you do that? So you can do either full depth repair or you can do partial through repair. So full depth means you have to completely cut off the whole area, and then you have to put a new core plug, and then you have to put the new um, face sheet, or you may only do partially, like you only need to do partial, and then you have to put the face sheet on top of that, and then you have to make sure that that face sheet matches the profile of the underlying substrate material. So they have several, some of these have advantages. So there are several softwares that are available for repair design and analysis. So it will tell you, suppose you input the material, input the information, it will tell you what kind of a repair method is most suitable for your application. It depends upon the type of structure, type of constructional structure. Okay, so that kind of, I mean, that finishes this part of this lecture, and I will finish that and save it and post it. Okay, thank you.